Right on academia. We are still on our series on differentiation. Okay, now today I'm going to be showing us how we can differentiate using our quotient rule. That is where our y, okay, our quotient rule. Alright, in this case where our y is a result of quotient, okay, let's assume that, let's say our y is equal to 3x divided by 1 plus x squared. So our y is a result of division, or is a result of division of two variables. Okay, now we still have our u and our v. So our first variable always remains our u. Alright, always remain our u, and then our denominator remains our what, v, our next variable. So the rule in this case, on when we want to differentiate our y and we are having division or quotient, okay, the rule that applies there is that our dy dx is going to be equals to v du minus u dv, alright, over v squared. This is our format, this is our rule. Alright, now we're going to be differentiating our u like we did before, holding our v constant, differentiating our v, holding our u constant. Okay, the one looking bigger is one that is constant for that case. Alright, now what we're going to be doing for this question is that we identify our u and our v. Okay, so our u is equal to 3x, right, and our v is equal to our denominator, which is 1 plus x squared. So in differentiating our u, alright, we differentiate our u in respect to our x, du dx. Since the power here is 1, when we multiply, we are just left with 3. Okay, 1 minus 1 becomes 0 on how to differentiate. So we have our 3, and then for the next one, differentiating our v in respect to x, we'll be having, since this is a constant, like I said before, when we want to differentiate constant, it becomes 0 because the power of our x in this case is 0. So 0 multiplying cancel, make the whole equation to be 0. Alright, so by that 0, we're going to leave that out. So we have 2 multiplied by our power, our constant, which is 1. We have 2x. Okay, 2 minus 1 becomes 1, so we are left with just 2x. Now, so let's simply input everything into our formula. Alright, our dy dx is going to be giving us what? Now for our v, this is our v, we have 1 plus x squared multiplied by our du, that's our differentiated u, okay, which is multiplied by 3. Alright, plus, okay, minus, sorry, minus is the difference we're taking, minus u. Our u in this case is our 3x, which is our numerator, multiplied by what? Our dv, which is 2x, divided by our v squared, our v, not our differentiated v, okay, our v squared, just our denominator, 1 plus x squared. Since it is a square, okay, the square will be outside the bracket. This square is from the equation, the inner square, but the format has v square. Alright, so we take our v and still square our v. Now let's solve in expanding. Now 3 multiplied by 1, okay, everything multiplied. 1 multiplied by 3, we have 3, and then plus x squared multiplied, we have 3x squared. Right, now minus 3x times 2x, giving us minus 6x squared. 3 times 2, and then our x times x. Alright, now we will not be expanding this, we can just still leave it in that form as 1 plus x squared all squared. Alright, now our next step, now look at our like terms in this case, right, and since they're already close, we just work on them. Now we have plus 3x squared minus 6x squared. Alright, so we'll be having 3 minus 3x squared over 1 plus x squared all squared. Now we can leave this as it is, or we can choose to factor out 3 from our numerator. Okay, if we want to do that, we'll be having our dy dx to be equal to 3. When we factorize, we'll be having 1 minus x squared, right, over 1 plus x squared or square. Now since the contents are different, here we are having a minus, here we are having a plus, so we have to be leaving our answer in this form, okay? But if assuming this was a plus and this was a plus, then we can cancel out one, all right? But since they are not common, we cannot cancel out, we have to be stopping here. So with this, we hope and we trust that you will be able to follow us on our quotient rule, right? Don't forget to like our videos, subscribe to our channel if you haven't, share our video with as many as you can. We'll see you in our next class. Thank you.